Hello, welcome to session number 5 in the series Embedded System Design. My name is Anurag Nigam. We are discussing embedded microcontroller, AVR controller 328P. And we have last time learned how to use some of the GPIOs, and specifically we were looking at analog input, right? Now the next thing which you need to look at is something called timing or timer, right? So here I have a data sheet of this 328P, and it shows the clock distribution. Now here you can see that this CPU can be clocked by a clocking control unit. So basically the clocks are generated by this clocking control unit. This clock goes to ADC, the clock goes to CPU, the clock goes to RAM, it goes to flash and EEPROM, right? And then the clock is also controlling the GPIO and asynchronous timer. So again, every clocking is coming from this clock control unit. And whatever you see green is basically these are the oscillators, okay, which are generating the timing signal, right? Now here there are two options there. One is crystal 1, crystal 2, and then there is a there are provisions for various kinds of oscillators. One is going to be the low power oscillator. So other one is going to be full swing oscillator. So basically low power oscillator is for low power consumption, but then it suffers from noise because its swing output swing is not from rail to rail. So in that case, this low power crystal oscillator has issues in a noisy environment. In that case, you would use a full swing oscillator. So all these things are there. Now whenever you use an oscillator, the oscillation takes time to build, right? So whenever you do a reset, you have to wait for a certain duration, and there is something called burnout duration, BOD, right? For that duration you would have wait a certain number of cycles before the oscillator stabilizes to a stable clock frequency, right? So all these things are there. If you refer to the manual, you can see the details of most of the stuff because everything is documented. It's all that you go through this and make sense of what they are trying to tell you, right? Again, when you use crystals, you can basically in that case also they tell you how many clock cycles it's going to take for for something like stable clock. So all these details are in there. So but anyways, the clock here is a 16 megahertz clock, which is the internal clock, and we are going to do all the referencing with respect to that. Now in this microcontroller, there are two 8-bit counters or 8-bit timers and one 16-bit timer. So we are interested in a 16-bit timer. So again, these clocks can be frozen. So they are gated clocks, right? So for example, if I want to put CPU to sleep, I will switch off the clock to the CPU. Also, when I'm doing a conversion, for example, analog digital, I might try to put to sleep most of the digital circuitry so that the conversion from analog to digital is accurate, right? So it is free from noise and stuff like that. So all those settings can be done here. Choosing the oscillator also, you can do a choice of oscillator also. But then here we are going to focus on timers or also counters. Now there are different modes in which you can operate these timers. These timers are nothing but they are like binary counters. Now these counters are driven by the system internal clock, internal RC oscillator, which is 16 megahertz. So if you want to generate something using this clock, whether the clock is for a certain peripheral, which may be a serial IO, or it can be a GPIO, or it can be a ADC, it can be a CPU, it can be anything to do with power management. You basically can do the timing, okay, by this internal RC oscillator, and then its frequency is 16 megahertz, so you can put in a prescaler, right? So first thing is you can divide this in the 16 megahertz clock to 2 raised to n kind of prescaler, in the sense that you can pre-divide the clock frequency and then use that frequency for something else, or running a counter, for example, right? So these things you can do here. So we are looking at 16-bit counter here. So we are going to run a 16-bit counter, and we are going to run a 16-bit counter. There are different modes here, as I was telling you. One is the comparator mode. In a comparator mode, for example, you can have a count starting from the initial value, and then it will reset at the value which is provided for comparison. So as soon as the upper limit is reached, it is going to raise an interrupt and reset the counter, right? So this is comparator mode. So you can use a counter in a comparator mode. You can also use the counter in an overflow mode. So for example, if I want to do n number of cycles, or rather if I want to do m number of cycles and total cycles is n, then I can feed into the counter something which is m minus n. So if the total cycles is m, and I want to count m minus n, so I can feed in n and start counting up to m, and it overflows, it is going to issue an interrupt. So this is the easiest way of using a counter as a timer. What you do is, there are two modes of doing it. One is the comparator mode, in which the counter always starts from 0, and then it counts to a number, and then that number is fed back again once that is exceeded, right? So that is the comparator mode. The other easy mode is you feed in a number and you let the counter overflow, and when the counter overflows, you can reset it back to the initial count. So that is what we are going to use. That's the easiest way of using the counters in here. And the whole idea is, I want to generate a clock, a digital clock, where I can set the minutes and hours, and I'll let it count, right? So I can update, minutes and hours. I should be able to set that. So we have a board which already has a 4-digit 7-segment display. We have got 2 switches which we are going to use, and one potentiometer, right? And that potentiometer is on A0. So we have to keep that in mind. So now if I go to the timer, 16-bit timer. So let me just go to 16-bit timer. Okay, so it can also be used, in PWM mode. So timers can be used to generate, some kind of a sawtooth waveform, stuff like that. So we will come to this later on, because there is no true DAC on it. So analog out is in the form of PWM. So here, what you are looking at is a 16-bit counter, which is called TC1. So this is a 16-bit timer counter, and it is also capable of pulse width modulation, right? So it's a true 16-bit design, 2 independent output compare units, right? So you can compare it to a word and then reset the counter. Then what is the important step? Clear timer on compare match. So when you use it in comparator mode, whenever there is a match between the word and the timer output, then it's going to clear. That is, it's going to go back to 0, 0, 0. Okay, so glitch free, phase correct pulse width modulation is there, right? It says variable PWM, pulse width modulation period, frequency generator, external event counter. So basically you can do like a stopwatch also, like you can issue an interrupt to stop it. So that kind of stuff is also there. The independent interrupt sources is timer overflow. Okay, OCFA, OCFB, ICF. So these are basically comparator modes. So I'm going to use timer overflow, TOV, as an interrupt to update the clock every second. So that's what we are planning to do. So let's see how easily we can use this. Without going into a lot of details, of course you can read these details. There are different control registers. So these are the important ones. Okay, so we will go to the control registers to see them. Okay, so let's quickly come to the control registers. So there are different modes which they have described. So if you have time, you can read about this. Later on, we will do some exercises maybe if it's interesting. Okay, so the first register, which is TC1 control register A, and the first 4 bits are for comparator mode on 2 channels, A and B. So according to me, they are going to be disconnected. So basically, I can set all these 4 bits to be 0. Okay, and then it says WGM11, WGM 10. Okay, so again, this is the waveform. So let's see what that WGM is. Waveform generation mode. So I'm not generating a waveform, right? So at the output, so I can put out a waveform which can be controlled by pulse width modulation. So I'm not doing that, so I'll set this also to 0 0. Okay, so so this is TC1. This register is called TC1, TCR1A, right? So everything will be 0 0 on this. Okay, so the next is TCR1B. So let's look at TCR1B. Okay, so this is also a control register. So let's see what it is going to do. Input capture noise canceller, input capture edge select. So this is 0 0. WGM 11 12, that's also 0 0. Then it says CS12 11 and 10. So let's see what is this. This is a clock select. So this is a prescaler. So before you give a clock to a counter, you can prescale it out, and the prescale factor is going to be like this. You can take the internal reference clock, which is 16 megahertz. You can divide by 1, divide by 8, divide by 64 to 56, and 1024, and so that's the divide ratio. So what we are going to do is we are going to take 16 megahertz and divide by 1024. So we are left with roughly 16 kilohertz or 15 kilohertz, right? So that 15 kilohertz is going to drive this TC1. Okay, and how many cycles should I count to make 1 nanosecond, 1 second? That's what we are going to calculate. So we are going to feed that. So here TCR1 TCCR1B is going to be 0.5 because we are dividing by 1024. So that is going to be 0.5. So TC, the previous one was register was called, just 1 second. Okay, so the previous register was called TCCR1A and TCCR1B. So TCCR1A is 0x00 because we are not using comparator mode, right? TCCR1A. TCCR1B is going to be 0x05 because we are using a prescaler of 1024, right? And then you have got 2 words. Okay, TCCR1C, it says force output compare for channel A and channel B. So this we are not going to touch. It is by default going to be all 0 0. Okay, so the next one is TCNT1L. So this is the count which you feed into a counter, right? So this is going to be the lower byte. So this is 16-bit, right? So this is going to be a lower byte, and then TCNT1H is going to be a higher byte. So we have to calculate these 2 bytes so as to make the counter overflow in 1 second. Okay, so that's the whole idea. So this is this one you don't have to worry about. Okay, so only thing is you have to worry about TCNT1H, TCNT1L. So these are the 2 bytes which you have to think about. So this is for the comparator mode, so don't worry about that one. Okay, so the next one which you need, so I think that's all what you need to do. Again, this is the last one. This is called timer mask register, right? Interrupt mask register. So here you will see TOIE, that is the LSP here, which says overflow interrupt enable. So you have to set this to 1. So then TIMSK1 should be set to 0x01. So 4 registers we are going to set here, and we will be in the business. Okay, so let's go ahead and modify the previous program. Okay, so what am I going to do? I am going to have hour set and minute set. Okay, for that I'm going to use the 2 switches, and these 2 switches are on pin change interrupt, which we have already configured in the previous code. Right, so I have increased, and the remaining program is going to remain the same. It's just that I am not going to use the display, which I was using for earlier purposes. So in this case, this display will go remark. Okay, so I am going to convert this into remark, so I'm not using display. Second thing is that, again, display character. So I am not displaying a character, I'm displaying hours and minute. So this function also I'm going to disable. Okay, the next thing is, wherever I am updating this, I am going to remove that. Okay, I'm updating this here, so this doesn't exist, so I'm just removing that. Next is display character. I'm going to disable that. Okay, so this is pin change interrupt. So I have just modified the pin change interrupt from the previous code. Now in this case, I am not displaying the display, so I'm going to disable these. Okay, so we are done with that. Okay, so now we are all set. All we have to do is, I am going to enable pin change interrupts for the 2 switches. Okay, so this is enabling the pin change interrupt. Okay, now the next thing I want to do is set the timer, right? So in that case, first of all, it is going to be, the potentiometer is on channel 0. So AD mux is going to become 0x40. Again, the prescaler for ADC is going to be CF. So we have already discussed in the session 4 what is ADC SRA for that. So I'm not going to touch that. All I'm going to do is add some things for the timer. So in this case, first thing I have to set is TCCR1A. Right. So this is going to be a very short tutorial. Let's hope so. Okay, where did it go? Okay, here it is. TCCR1A. That is, we have decided as 0x00. Okay, TCCR1A is equal to 0x00. Fine. So in this case, what did we do? Not using compare mode. So that's why I'm disabling that. Then we have TCCR1B. Okay, TCCR1B. So in this case, I'm setting the prescaler. So this is 0x05. Right. So I'm prescaler by 1024. So I will say internal clock prescaled by 1024. Right. So now we have to do some calculation. Okay, that calculation has to be fed into the start count. Okay, so in this case, let's look at these words. These words would be called, these words will be called TCNT1L and TCNT1H. Okay, TCNT1H and TCNT1L. Right, so we have to just set these two every time the counter overflows. So we have to feed some count in here. So how do we calculate that count? Okay, so let's go to calculator. Okay, so this is decimal here, and I have got 16 megahertz. So this is 16 megahertz, right? And I divided by 1024 because that's the prescaler. Okay, so my count is going to be 15625. Okay, so this is the clock into the counter, and I have to divide by that. So this is 3D09. Okay, so the overflow will occur. It should have counted these many cycles. So the highest count is FFFF. So this is 3D09, right? So let me go to hex and say 3D09 FFFF minus 3D09. So this is going to be C2F6. Okay, C2F6. Okay, so this is what we have to feed here. Okay, and yeah, so this is what we have to feed here. Okay, so I will feed here 0x C2, and here 0x, and you know this is going to be slightly inaccurate here. C2 F6, right? Okay, C2 F6. We'll see, we'll run a stopwatch and see whether it is F6 or F7, but it will be in that vicinity. Okay, so here I'm going to add a remark. Initial count in TC1. Okay, so this is my initial count in TC1. So we are all set. Okay, now the next thing is I have to write a display routine. Okay, so for display routine I'm going to do the following. Okay, I am going to have volatile unsigned character, and in this case I'm going to have hour, minute, and second. Correct? Okay, hour, minute, and second. So these are going to keep the track of timing, and these being global, they have initial value of 0, right? So that's done. And then I would use one flag. Okay, so I will use called status. Now later I want to modify this timer to have alarm, to have stopwatch and stuff like that. So I would put here something called status, and I will be in status 0 to start with, and if I want to set something, I'll be in status 0, and after I have set the time and I want the clock running, I'll be in status 1. So basically status 0 is time set, and status 1 is going to be your running clock. Okay, so that is going to be 0 0. So when I start the clock, the first thing I'm going to encounter is set the time, right? Okay, the next thing I'm going to say is volatile okay, bit. Okay, so that bit I am going to say is hour set. So if this hour set is 0, I'm setting the minute, and if it is 1, I'm setting the hour, right? So this is as simple as that. Okay, so the next thing is, what am I displaying? Okay, so display routine I have to write. So I will write here a display routine. So I will say void display time, and here I am going to pass in unsigned character hour and unsigned character minute. So these are local variables. We have a global variables by the same name. So inside this, whatever is edited is going to be local only. So first thing is I'm going to create the same thing, which is called unsigned character, right? So unsigned character CHR. Okay, and this is going to be like four digits, right? And then I'm going to say whatever is the, so I will set the the minute and the hour, right? So what I'll do is I will say CHR 0 is going to be the lower digit of minutes. So that's going to be CHR 0 is equal to minute mod 10, correct? And then CHR 1 is going to be minute divided by 10. So this is going to be the minute count. Then you have got CHR 2, that is going to be the hour count first digit. So it will be HR mod 10. And let me see if I'm recording. Okay. And our count, the second digit is going to be CHR 3 is going to be HR by 10. Right, so we are done with this. The next thing is I want to display it, so I have to convert the decimal into 7-segment code, for which I've already written the function, right? So I have to just set the global variables CO0 decimal to 7-segment, and then just do the CHR0, CHR1, CHR2, CHR3, and what it is returned into CO is going to be the 7-segment equivalent of the digits to be displayed. So we are done with that. Okay, so when we come here, what do we have to do? Okay, first of all, I am in the when I enter, okay, my flag is called stat, and the flag is going to be 0. So I will say if stat equal to 0x 00, then HR set, right? HR set. So HR set would be equal to so I'm going to toggle HR set. So HR set is initially 0. That means I'm setting the minutes. So I will toggle this like this. Okay, so this will be if I have a stat 0x00, I'll be toggling whether I'm setting minute or am I setting hour. And here, if I have the other switch, I'll be toggling the status. So in this case, I would just do stat toggling the LSB, right? So for that, I can use a XR and 0x01. So this is going to toggle the status, right? If it is 0, it will become 1. If it is 1, it will become 0. So when I am in the stat of 0, 0, I am either doing an hour set or I'm doing a minute set. Nothing else. When I am in step 1, I am not doing hour minute set. Okay, so in this case, I have to say if stat is equal to 0x01, let's see, if I am in the status 00, I'm toggling HR minute set. So if I am in 01, then I am enabling. Okay, so I will need a first press. So when I log in, I'll be in the clocking mode. So 00 status would be meaning clocking mode. Okay. And when I toggle it to 01, okay, then I'll be enabling the ADC. So I will be saying ADC SRA is equal to 0x CF, which we have already discussed, else ADC SRA is equal to 0x C0F. So I have disabled the ADC interrupt. Okay, so when I am in status 01, I have enabled the ADC and I'll be reading the potentiometer, and I will be doing hour set and the minute set. If HR set is 0, I'm doing minute set. If HR set is 1, I'm doing hour set. When I again press this pin, I will be toggling back to 00. Okay, so at that time the clock would be running and ADC would be disabled. Right, so under 01, status is 01, the ADC is enabled and it is reading what hour and minute I'm setting using potentiometer. And when it is 00, I'm disabling the ADC. Okay, so that's there, and here I should be calling display time, and in that case I'll be passing HR and minute. Right, so this is very simple. Now the next is whether I'm setting minute or hour, right? So if HR set equal to 0, then I'm setting minutes, right? Okay, right. If HR set is 0, I'm setting minutes. Else I'll be setting hours. Else I'll be setting hour. Right. So when this happens, minute is coming in. So I will say minute is equal to float of ADCW divided by 1023 multiplied by the highest count. The highest count on minute is going to be 59. Correct? And then hour, HR, and that HR would be set with a float of ADCW, right? Because we are not doing the integer division, we are doing the floating point division. Otherwise, you'll get 0 or 1 only, right? So 1023 multiplied by 23. So let's see what it is. If ADCW has a count of 1023, that means set the minute to 59. If ADCW is 0, then set the minute to 0. If hour, okay, has ADC output as 1023, it will set the hours to 23 hours. Otherwise, if it is 0, it will set it to 0. Now, the next thing is it will by itself do a casting, because minute and hour are integers and what is on the RHS is a floating point. If you want, you can cast it to an integer, and in that case I will take this and put it in a bracket. Hang on a second. Okay, so what might have happened is, let's see if this is still working. Let me just do a scene change. Hang on a second. Something happened here. Let me correct that. F12. So that means that, okay, this is frozen. Let me put you on a pause and let me correct this first. Function. Okay, welcome back. So what happened was my camera turned off, so I had to turn it on. Okay, so now it's okay. Okay, so now what we were talking about was I have casted it to float. And here, again, before assigning, I've casted it to integer, not float, sorry. Okay, so I am casting it to not integer, unsigned character. Okay, so let's make a change. It's not an integer. Or you can just say character if you want. Okay, so here it is updating the hour and the minute settings, right? And every time it's reading, it is enabling the ADC SRA for start conversion bit. So that's what it is doing. Okay, so this is fine. So what is happening here? What's happening is the pin change interrupt, okay, sets the hours and minutes, right? And once they are set, it is going to disable the ADC. Okay, and that is controlled by one of the buttons. Okay, then you can toggle between, when you are setting the time, you can toggle between hour and minute by using the other button, by toggling HR set, right? So this is all set. Now we have to do one more function which will be updating the time. So here I have to call in display display time, and I have to call it with hour and minute. Okay, so I'm calling that function display time. So if you see, let me check. Okay, so that's basically display time. I'm calling this display time. Okay, so that's done. Let's see in the main, what am I calling? Because I have to refresh it, so I don't have to call anything. CO is being displayed. Okay, so this is going to be remaining as is. So nothing over here. All I have to do is write a overflow function, interrupt. Okay, so to do the overflow interrupt, I can write it almost anywhere. So I will write it over here. I will call this as interrupt, and this will be timer overflow. So I'll go to mega and look at the vectored this thing. It says TM1 TIM1 OVF. So this is timer 1 overflow, right? So that's what routine we have to write. We have to write TIM1 underscore OVF, timer overflow. Let's check this once more. TIM1 OVF, that is vector 14, and then this is going to return void, and this is going to say update time, right? And it's going to receive nothing because that thing is a global. Okay, so here I would do sec plus plus. So that means I am updating seconds, right? Because every overflow means updating the seconds. Okay, so as soon as I update the seconds, I'm going to check if second is equal to 60. Okay, so if seconds is equal to 60, then what do? I will update the minute, right? So I will say min plus plus. Okay, and I will set the second to 0, and I will call the display routine, display time HR comma minute. Correct? Done. Now next thing I'm going to do is, if a minute is equal to 60, so then the hour has to be updated. If init is 60, then I would say HR plus plus, right? And then minute equal to 0, correct? And then I will call display time. Okay, hour comma minute. Okay, the next is, if hour has become 24, then I have to reset the hour to 0. Okay, then I have to just simply do HR plus plus. Okay, and at the end of it, okay, so this is the overflow interrupt, right? So at the end of it, whenever I'm updating hour, I am also calling the display, right? So I'll put this in a bracket, right? So I'll put this in a bracket here, and inside this I am going to call back, sorry about that. Okay, I am going to call here display time, and I will again update the hour in minutes, right? So this is done. Now I have another thing to do. I want to blink LED, okay, which is basically the second digit DP every even second. So I would say if SAC mod 2, okay, if SAC mod 2, I will take CO2, and to that I would say I have to set it, right? So I would say, sorry, or equal to 0x, so 0x80. So I'm setting the DP to be 1. Okay, else I'm setting the DP to be 0. So that will cause so to set DP to 0, I will do a AND with 0x 7f. So the remaining word remains the same. Okay, so this is a very simple routine to blink the dot between the two digits, hour and minute. So that will blink every even second, or every second it is going to blink that. Okay, so that's done. Next is I will have to reset my count into the counter. So my count which I'm feeding here is C2 F6. So this C2 F6 has to be fed back in again. Control C, and over here C2 F6 has to be set back again. Okay. Okay, so I have handled the timer overflow interrupt to update the seconds, and I am blinking the dot, and I am doing second update, second minute update, and hour update. If they exceed the upper limit, I'm resetting them. If hour equal to 24, it should be hour is equal to 0. So that's a mistake. Right? If hour is equal to 24, hour is set back to 0. So that's correct. Okay, so this is done. Let's look at ADC. It's also working correct. And enabling and disabling the ADC, that's spin change interrupt. So the status is 0, it is running the clock. Status is 1, it is updating the clock set by ADC, right? Or it is simply counting. Correct. So I think we are all set. So let's program this. Project build all. Okay, incorrect assignment. So let's just check what happened here. 48, 53, 72, 91. 48. Okay, so it is not an assignment, it is a comparison. 58. 53, sorry. 53. Again, this is 53. So this is a comparison. 72 and 91. Let's see what is 72. Okay, 72 is again comparison. Hours and seconds and minutes. 72 and 91. 91 is what? Okay, again, it is assignment. Okay, these are the silly mistakes people do, but it gives you a warning. It's a build up. Okay, and program chip. Okay, is the counter running? First of all, it will run when the overflow comes in, right? So the overflow should be coming in, isn't it? So it should be blinking. Second should be updating. It's not blinking. Let's see what happens. Okay, so let's see here. Okay, ADC is not enabled. Okay, so I have some issue here. Okay, let's fix this. Okay, let me put you on pause and find out what may be the reason. Okay. Okay, so I know what happened. You remember I have to enable the overflow interrupt, right? And that is set by Tim mask 1, right? So Tim mask 1 is over here. Okay, this is this one. Tim mask 1, TIMSK1. Okay, Tim mask 1, the overflow enable has to be, so it has to be set to 0x01. Okay, so I'll do that first. Okay, so here Tim mask 1 equal to 0x01, right? So this will enable overflow interrupt. Enable timer TC1 overflow interrupt. TC1 overflow interrupt. So that's why the overflow interrupt is not coming, right? So let's see this again. Let's get this out of the way. So now it should be coming, isn't it? Okay, let's burn this again. Okay, undefined. Oh, MSK, not MASK. MSK. Okay. Project build all. Program check. Okay, so you see that dot which is blinking. Okay, let me put you onto the main screen. So scene change. Okay, so you can see that second dot is blinking, right? And the time has been set to 00, 0 hours, 0 minutes. So if you let this blink, okay, so I hope you can see that. If you let this blink for 60 times, or rather 30 times, this will update the minute to 1. So let's just check that. And then we will check the functionality of setting the time. Okay, so bear with me. Anytime it will update to 1. It went to 44. So there was a problem here also. Let me fix this function. Okay, let me fix this problem. Let me put you on hold. Hello. Welcome back. Yeah. So what happened was there were one or two things which I have to correct. One thing was initially I am putting the ADC to be disabled, right? So to start with, the ADC is disabled. Now that means that the count will start from 0 because ADC is not setting the minutes or hours, and you will see that once I burn it, now the minute has updated to 1, right? So I started with 0, minute is updated to 1. Okay, the next mistake which I was doing was when I was setting the hours in minute, I was not updating the display. So this statement was not there. So I added this statement so that when I update minutes and hours, I actually have to update the display, right? So when the ADC is enabled, it has to update the display. Okay, so that's the second thing which I changed, and the remaining things are the same, right? So what I have done here is, okay, another thing was, if the status was 0, I am enabling the ADC, and if it is 1, I am disabling this ADC, and I am running okay, I am running the clock. Okay, so okay, okay, hour and minute are updated on 0, and if it is 0, then ADC is updated, and if it is 1, then this toggling has no meaning, and the ADCs are disabled. Okay, fine. So I am going to burn this, build all, and program chip. And then I'll put you on the main screen. Okay, so now you can see the main screen. It is blinking, means that the timer is running. Now here I have to click this to the top button to set the time, right? So now here the minute is being read from this potentiometer. So if I was to change it, I can set it to 0, or I can set it to any minute up to 59. Right. So this is there. Now the next thing is, this is going to switch to hours. Now I can use the same part to set the time to something like, let's say, 5 hours and 59 minutes. And once I'm done with this, I set this button again to set the timer in motion. So it has become 6 o'clock. Now it is running that. Now what next I want to do is, I want to run a stopwatch to see if my timing is correct. Okay, so for that I need take help of a stopwatch. Okay, so let's do that. So now this is keeping the time. Okay, I have set it to 6 right now, and let's set a stopwatch. Okay, so I am going to put a stopwatch by its side. Okay, let me make some adjustments here. Okay, so that's going to be the stopwatch, and hang on a second. And as soon as it becomes 2, I am going to start running the stopwatch. Okay, so this is 1 minute. So 6 1. So I may not be very accurate in clicking the hit. Okay, I didn't start it. Okay, anyways, I started it now. So I was delayed. I was delayed by a few seconds. So we will do it another way. So right now it's 30 seconds. So at 53 seconds, I had the update. So at 1 minute 53 seconds, I should see the next update. So at 53, I had an update. At 1 minute 53, I should see the update. So at 1 minute 53 seconds, I saw the another update. So basically, I am counting minute wise. Minute wise, I'm accurate. So this is keeping the time. Okay. So this is a very simple example of a clock, right? So I hope you can see the lighting is okay. Okay. So what this is now you can set the time. That means that you can set an alarm, or you can set any time. So let me just swap back. Okay, so that means that in this program you can set the time. So now it's a question of just programming the stat. Okay, so if stat is 0, then I'm enabling ADCs and I am taking hour and minute setting. If stat is not 0, okay, then I am doing something else, right? So if stat is 0, I can toggle hour and minute and then set them separately. But if stat is 1, right? Then I'm keeping the time. So at that time the ADC is disabled, and the vector interrupt, the overflow interrupt takes over and keeps the time. Okay, so what is the application of this? The application of this is can be many. Okay, you can have built up any kind of a machine which basically does some operation from time to time. So basically that means that you can sequence various mechanical actions. Okay, it may be a conveyor belt, it can be any mechanical gadget where you can sequence various operations using motors, right? So timing is very important factor here, right? So once you can keep the time, you can sequence the events, and once you can sequence the events, you can create any complicated machine which basically goes from one state to another. And then you can bring in your state machines, and then you can have more complex machines, like you can do you can do some kind of a sorting, you can do some kind of any mechanical process which has steps in it, you can do that. Okay, so that's the whole motive of today's session, was to introduce you to timing. Okay, thanks a lot. Thank you.